All right, today we're going to review all the methods for solving a quadratic that we have learned about. Again, to solve a quadratic, you have to set your ax squared plus bx plus c equal to 0. Here are the three methods we've talked about. One method is factoring. We've also talked about solving using square roots and specifically completing the square. And we've talked about solving a quadratic using the quadratic formula, which you see here. I also want to review with you that the discriminant, which is this piece of the quadratic formula underneath the square root, that plays a very important role. That one calculation right here can tell us how many solutions we have in our quadratic. Okay, so if our discriminant, if we put in our values of b and a and c and calculate this whole thing, if we get a positive number, that means that we will have two real solutions, which means that our quadratic will have a solution or two solutions, two x-intercepts. If we plug this in and calculate the discriminant and it's equal to 0, that means we will have one real solution. And so our graph would look something like this, where our parabola just touches the x-axis in one place. If our discriminant, when we calculate it, is equal to a negative number, that means that there will be two imaginary or non-real solutions. This is something that you'll explore more in Algebra 2. For Algebra 1, if we have a negative number, basically we can say we have no real solutions, which means our parabola or quadratic is not going to touch the x-axis. All right, so we're going to take some time and review each of these three methods. We're going to start with factoring. Okay, so factoring is really helpful. I've got a kind of a basic one set up here, x squared plus 5x plus 6 equals 0. And anytime we're factoring, we want to look at our constant value, our c value, and ask ourselves, okay, what numbers multiply to make 6, or what are the factors of 6? And I've listed them out here. 1 times 6 is 6, and 2 times 3 is 6. Now we want to choose the pair of numbers that also adds to give us our b value right here, our 5. So 1 plus 6 does not add to 5, but 2 plus 3 does. Okay, so since these add to equal 5, these are the numbers that we're going to use in our factors. So this will become x plus 2 times x plus 3. And if you multiply this out using your area model, it will get you this answer here. Now, to find the solution, you can see this is set equal to 0. So we're going to set each of these factors equal to 0. So x plus 2 equal to 0. And we know that if we subtract 2 on each side, we get x equals negative 2. We could have also realized that by knowing that to make this quantity 0, this would have to be basically a 0 pair with this number. So likewise over here, if you think about the 0 pair with positive 3, that would be negative 3. So negative 3 is our other solution. All right, here is a more complicated factoring problem. This one has a coefficient bigger than 1, and unfortunately, there's no greatest common factor. At first, I thought I could divide all of these by 3. However, 16 is not evenly divisible by 3, so I have no greatest common factor. So that means I'm going to use this x method that we learned about. So I know that a is 3, that's the leading coefficient here, b is negative 16, and c is negative 12. So when I use my x method, at the top of my x, I'm going to put the product of a times c. So 3 times negative 12 is negative 36. And at the bottom of my x, I'm going to put what b is, and that's negative 16. Then I have to ask myself, what are the factors of negative 36? So I start with 1. I know 1 times negative 36 will give me negative 36, as well as 2 times negative 18, and 3 times negative 12. And I could go on with some more, but I notice here that if I were to add 2 and negative 18, that would give me negative 16. So I can see already that I have the pair of numbers that will solve this puzzle. So this over here is going to be 2, and this is going to be negative 18. And now we're ready to start thinking about writing out in factored form. First of all, for this, since the coefficient is 3 and not 1, we have to take this 2, and we have to divide it by 3, because that is our a value. And that's going to give us, of course, 2/3. We'll leave it as a fraction. Then we're going to take negative 18, and we're going to also divide that by our a value of 3. And that's going to leave us with negative 6. Okay? So that means when we write our factored form, you can think of this as negative 6 over 1. We are going to have the 2 will become the coefficient in front of x, and the 3 will become the constant in our factor. So 2x plus 3. And over here, we will have, oh, I'm sorry, I did that wrong. The numerator should be here. So we'll switch that around. And the denominator should be here. Okay, so again, I had that wrong. The 2 comes down here as our constant. The 3 is in front here. Likewise, here, the negative 6 is going to come down and be our constant. And the 1 is going to be in front of our x. You can write the 1 there, or you can just leave it as an x. So our two factors are, and I will dot here to know that these should be multiplying. Those are our factors. Okay, well, those are equal to 0. Now, when we solve this, we can set 3x plus 2 equal to 0. And then we can subtract 2 from each side. That'll give us 3x equals negative 2. And then our last step will be to divide 3 on both sides. So our x value will equal negative 2 divided by 3. Notice our solution is just the opposite sign of this value here. So if we think here, this value here was negative 6, our solution is going to be the opposite of that. So this would be x equals positive 6. So if you want to, you could stop at this point and just change the signs to get the solutions. Okay, and finally, here's one more. This one here, we can see that our c value is 7, and we need to think of factors of 7. And that's a prime number. That's only going to be 1 and 7. However, 1 plus 7 is not going to equal 10. So in this case, we cannot use factoring because this is not factorable. Okay, so factoring is a great method, but it will not always work when you're solving a quadratic. So we're going to come back to this one later. Okay, so let's take a look at our second method, which is our square roots method. And this is also going to include completing the square. For the square root method, and this is just basic problem here, we are almost ready to just do the square root. But before we can take the square root, we have to divide by this 2. So we're going to go ahead and do that real quick. Divide by 2 on each side. That gives us x squared equals 36. Now to undo the square, we're going to square root. And that's going to leave us with x equals positive and negative 6. Over here, we don't have any multiplier out front, so we can go ahead and right off the bat, we can take the square root of this whole quantity. That will cancel out the square. We're going to take the square root of this as well, and this will give us, we don't need those parentheses anymore. We'll do x plus 3 equal to plus or minus 7. And then from here, we need to subtract 3 on each side. So that's going to give us x equal to negative 3 plus or minus 7, which means we'll have negative 3 plus 7, which is going to give us a positive 4. And we have negative 3 minus 7, which is going to give us a negative 10. So those are our two solutions. Okay, so here we just use square root, nothing fancy. Down here, we're going to start reviewing some problems where we will have to complete the square. Okay, so in this problem here, we have our quadratic. The first thing we want to do is we want to take our c value and move it to the other side. So we're going to add 5, as you can see I did here. Then we have to make a perfect square. Okay, to do that, we have to take this value here, this b value, and we have to divide it by 2 and then square it. Okay, so 8 divided by 2 is 4. 4 squared is 16. So 16 is the number that we need to be adding to each side. And we have to add it to each side of the equation to keep it balanced, to keep it equal. All right, once we do that, this is now considered a perfect square, because if we take x plus 4, and again, that 4 is coming from this number that we got by dividing our b divided by 2. If we do x plus 4 times x plus 4, that gives us this quadratic. And x plus 4 times itself can be written like this, x plus 4 squared. Then on the other side, we have the 5 and the 16, which make 21. Okay, at this point, now it kind of starts to look like the second problem here. And so we're going to complete this the way we did this problem. So now we're going to square root each side. The square root will cancel the square, leaving us with x plus 4 equals the square root, well, plus or minus the square root of 21. Then we're going to subtract 4 from each side. Okay, so our final answer will be negative 4 plus or minus the square root of 21. So that's going to be negative 4 plus the square root of 21 and negative 4 minus the square root of 21. Okay, and then we have another problem down here. You can see I've already started by subtracting 3 from both sides. However, when I now start to think about what makes a perfect square, I have a problem. This b value is an odd number. So if you think about it, what's the first thing we do with our b value? Well, we divide it by 2. And negative 9 divided by 2 is not an even number. It's a decimal. So it's going to be negative 4.5, and then we're going to end up squaring that, and it's going to be a yucky number. So because this is not a whole number, that means that completing the square is not a good method to solve this. And so we would use a different method. And we'll get back to this very quickly. Okay, so all of that was completing the square. And finally, all this culminates in really what's a lot of times considered the universal method for solving a quadratic, the quadratic formula. This is considered to be universal because it works for any quadratic. Whereas factoring and completing the square had some limitations, this will work for everything. Okay, so we're going to run through this example. I've done most of it already so far. But if we look here, I've identified my a as 1. There's a 1 in front of the x squared. My b is 10. My c is 7. And so I just plugged in, following this formula, I took the opposite of b. So negative 10 plus or minus the square root of my b squared minus 4 times my a times my c, all divided by 2 times my a. And then from there, I simplified. Okay, you can see that I took 10 squared and got 100. And I did negative 4 times 1 times 7 and got negative 28. 2 times 1 is 2. From there, I continued to simplify. 100 minus 28 is 72. And this is how, as far as I got. Now we're going to continue the rest together. We need to continue on and simplify the square root of 72. So I like to think of perfect squares that can divide into this. And I happen to know that the square root of 36 times the square root of 2 is going to give me the square root of 72 because 36 times 2 is 72. Now, 36 is a perfect square. So when I square root it, I get 6. And then the root 2 comes down with it. So now I can write this answer as negative 10 plus or minus 6 square root of 2 all over 2. Okay, and then here I can divide the negative 10 by 2 and I can divide the 6 by 2. So negative 10 divided by 2 is negative 5. 6 divided by 2 is 3, so this will become plus or minus 3 root 2. Okay, so my two final answers are negative 5 plus 3 root 2 and negative 5 minus 3 root 2. Okay, one more example. I wanted to return to the one that we couldn't do with completing the square. If you didn't notice, the one we just did was the factoring one that we couldn't do. This one here, I started by setting the side equal to 0. I subtracted 5 on both sides, and that gave me this. I identified my A, B, and C, and then I plugged into my formula. So I took the negative of my B, or the opposite of negative 9, plus or minus my B squared, minus 4 times A times C, all over 2A. And then as I simplified that, negative 9 squared was positive 81. Negative 4 times 2 is negative 8. Negative 8 times negative 2 is positive 16. And you'll notice here the opposite of a negative, or a negative times a negative, is a positive. And I didn't have to write that plus sign there, but I did. Okay, and then the 2 times 2 is the 4. Okay, then from there I added the 81 and 16 and got the square root of 97. And from here, 97 cannot be broken down. It's not divisible by a perfect square. And 9 divided by 4, I guess I could reduce that because no, I can't, because that's not even. So this is as simplified as it can be. So if we wanted to write this as 2 separate answers, this would be 9 plus the square root of 97 over 4. And then 9 minus the square root of 97 over 4. Okay, so to review, the 3 methods that we've learned about are factoring, square roots, which includes completing the square, and the quadratic formula. And the quadratic formula is kind of nice because it works for all problems.